So we're going to talk about combining probability distributions. So we're going to work on adding and subtracting random variables of x and y. So as you can see, with taking the mean values for this, we'll be able to, the addition of mean for x plus the mean of y is simply adding the two means together. And for the subtraction, this simply would be subtraction. If we were to take, we're looking at this one, the mu of x minus y is equal to mu of x minus mu of y. Just as we did over here with plus, we use the addition sign. The only trick to this is when you're actually finding out your standard deviation. So if you take standard deviations and you're trying to add these two, well, you go through this equation right here. It's square root of the variance of x plus the variance of y. And then you'll notice a little trick here. If you look in this one, for the variance of x minus y, it's the same equation. That's not a, I didn't miswrite it or anything else. That's the actual equation, okay? So that's a little trick you need to catch up on and remember, okay? So with this, let's look at a problem and figure these out. So after much thought, I finally decided on the permanent employee wages, which are randomly assigned using the probability distributions x given below. So as of yesterday's assignment, we were talking about those wages by pulling out a piece of paper and picking those out. Well, I figured out what I want to give you guys. So additionally, at the end of the year, I will give my employees an hourly raise. The bonuses are assigned randomly according to the probability distribution y that are given below, and x and y are independent. So that is key. Don't forget this, independent. Okay, so they're independent. So here are the values that we're going off of. I'm going to give you set up with $9, $12, and $15. And then the probabilities of getting those. So to start off with this, let's talk about actually just getting the mean, the variance of standard deviation for these hourly wages of x. And to do that, easy way to do it, if you don't have a calculator, is to use Staplet. So in Staplet here, we're just simply going to go to one quantitative variable. And I'm just going to name this wages, okay? And for our wages, we had, let me scroll up here, 9, 12, and 15. So we had 9, 12, and 15. And let's begin our analysis. And there we go. We got a mean of 12. All right, so we're going to find a mean, variance, and standard deviation. So to calculate that mean, we got to use that equation, right? So for our mean, sigma of x values times the probability, right? So for this, we're simply going to take 9 times 0.3 we're going to take 12 times 0.45 plus 15 times 0.25. Let's see what we get. So 9 times 0.3 plus 12 times 0.45 plus 15 times 0.25. All right, so we're going to take 9 times 0.3 plus 12 times 0.45 plus 15 times 0.25. We should get 11.85. So for this, we got 11.85. So now let's find our standard deviation. For our standard deviation, remember that equation is square root. We got the sum of our x initial minus our mean, all times the probability initial. So for these, we should get, we're going to have 9 minus 11.85. Oh, forgot about squared. Squared up there. Squared times a probability of 0.3 plus 12 minus 11.85 squared times 0.45 plus 15 minus 11.85 squared times 0.25. I'll put in the calculator and figure that out. All right, so we should get 2.22. So we'll say we got 2.22. Now to get our variance is simply your standard deviation squared. So for this, variance, standard deviation squared. So if we square that value, which in other words, if we just don't take the square root, like we did up here in the first part of this problem, but we'll just do it so everybody sees what I'm talking about. Maybe just square it, you should get 4.93. Okay, so we got those set up there, and we're going to see what happens when we change these values. All right, so let's say annual hourly raise. Okay, so what's going to happen to these values here? So let's find out the mean, variance, standard deviation for these y values. Okay, so for our mean, we just simply take $1 times 0.7 plus $3 times 0.3. And we should get, and then if we were to take these values to find our standard deviation, so we should get 0.917, 0.917. And with that, again, we're just going to square it to get our variance. So if we were to go back to our calculator and just need to square that answer, we should get 0.84. All right, so with looking at that, now let's see what the probability of an employee being assigned a $9 wage and a $1 raise. So if we want to find the probability, we'll say a $9 wage and a $1 raise, simply because initially, right, we said that these are independent. So we can use a general multiplication rule because they're independent and take the probabilities for each one of those values and multiply them together. So we have 0.3 for our 9 and 0.7 for our 1. So again, we're taking the probability of getting a $9 wage plus the probability of getting a $1 raise. I'm sorry, not plus. Times. I'm thinking right. All right. So again, for our $9 wage, we're looking at 0.3, 0.3 times our $1 probability was 0.7 and that should come out to 0.21. Okay, so now we're going to look at this, and we're going to add these two and see what our total wages would be overall, right? We're going to take our actual wages and we're going to add this annual salary. We're going to make a table and come up with our probabilities for these. And then we're going to find the mean, variance, standard deviation for all those guys and see how they really changed. So again, if we were to take these values, which we had, our wages were $9. So again, our wages we have were $9, $12, and $15. And we had for the actual raise the option of $1 or $3. So we're going to combine these. Again, we're using, we're going to find our end values, which is x plus y. So again, our x's are the blue, our y's were the orange. So if we add those up to get our end values, so we get 9 plus 1 gives us 10. And then we had 9 plus 3 gives us 12. 12 plus 1 gives us 13. 12 plus 3 gives us 15. We have 15 plus 1 gives us 16. And then 15 plus 3 gives us 18. So we should have these values up here of 10, 12, 13, 15, 16, and 18. Now, for these setups here, because they're independent, we should be able to just simply multiply the probabilities by the probabilities for each of these wages. So, because we had a $9 value of 0.3 and a $1 value of 0.7, like we did in our example here, that would give us a $10 overall salary or overall hourly wage. So therefore, we had a 0.21 probability. So we knew that right here off the bat. We knew we had the probability of 0.21. Well, then to find 12, we took 9 and added 3. So we're going to take 0.3 times 0.3. So we took 0.3 times 0.3, we should get 0.09, and so forth. You're going to do those. All right, once you have those probabilities out there and everything, now let's go ahead and see what our mean is for the end values. Again, we go through the same calculations for figuring out our mean values. For the mean values, again, the overall expected mean, we're simply taking sigma, which is sum of our x values times our probability values. And then we're going to find our standard deviation, which is simply taking the square root of the sigma of our x values initial values minus the mean squared times the probability for each one of those x values. And we should come up with, when we work these out, 13.45 is the mean, and our standard deviation was 2.40. And then if you simply square the standard deviation, you get the variance of 5.76. All right, so now you should see, like we talked about up here in the overall big ideas. So as you can see up here in the big ideas that we talked about, we should have the values from these equations. As far as saying for our mean, we should be able to take the mean of the x that we got, the initial wages, plus the mean of the raises, add those up. That's what we should have got for the mean for those end values, the last mean that we got. Let's look at that. So if we were to sit here and look at this and say our mean we got was 11.85 plus 1.6. So we took 11.85 plus 1.6. That's 13.45. And isn't that what we got right here? 13.45 for our mean. So our mean overall for this, the mean of n was the mean of x plus the mean of y. For our standard deviation, you should have seen that this is simply taking the square root of the variance of x plus the variance of y. We should get that same answer. So for our variance of x was 4.93. So I'm going to go ahead and get this started so I don't forget them. 4.93 plus, and we had the variance for our y's was 0.84. And we should get 2.4 for our standard deviation for our n values, in which case we did. So these standard deviation for the n came out to played out to be, I should say, the square root of our variance for x plus the variance for our y's, and that gives our standard deviation. And then we usually find the variance for our n value, simply because we just needed to square the overall standard deviation for our n's. All right, so I hope that explains a little bit more, again, these equations and how they play out and how it works out, and I'll see you next time.